Okay, so we're going to talk about the law of sines again, but this time it's a different case. So in the first video, we had two angles and a side. So we either had angle, angle, side, or we had angle, side, angle. And in either case, this defines a unique triangle. If you have side, angle, side, which we'll see in the next section, this gives you a unique triangle. So if your sides and your angle in between is determined, there's only one way to finish the triangle. However, if you have side, side, angle, your triangle may or may not have one solution. So first what I'm going to do is convince you that that there may be more than one triangle if you don't have side, angle, side. Okay, so in this example, A is equal to 5, B is equal to 4, and beta is equal to 30. So I have A equals 5. So I'm going to show that. Maybe. Okay, come on. There. Okay. So here's my side A that's equal to 5. And side angle beta is set at this 30.72 degrees. Okay. So I have this setup. So I have A, I know A is 5, and I know that this angle is 30.72. I also know that B is 4. But, where is it? If I draw a circle, so B is going to go from here to somewhere on this side. But it has to be done so that B is equal to 4. So if I create a circle whose radius is 4, then what happens is I get two places where this ray intersects the circle. If I pick this one, if I pick this point of intersection, it makes this circle, this triangle. Okay. And come on. So this angle is 30.72, and this would be 8.96 degrees. And then I would be able to find the angle up here, this angle alpha. So there's one triangle. But there's a second triangle. Now this one's still 4. See if I put that, that's 4, and that's 4. If I choose this value, then I get a different angle measure here. So this angle stayed fixed, and these two changed. So this was fixed, A was fixed, this angle beta was fixed, and B was fixed. But I didn't have enough information about the side C or the angle in between A and B. So I could come up with two solutions, two triangles that satisfied the given information. So that can happen when you have this side-side angle set up. Okay, so let's do some examples where we solve the triangle when you have side-side angle. Now, the really confusing part is just because you have side-side angle doesn't mean you only get it doesn't mean you always get two triangles. Sometimes you just get one triangle. So that's the difficult part. Do you get two triangles or one? Okay, so here is, it's not quite the problem we just did because this was 30 degrees and what we did was 30.72. So it'll be close. Okay, so I have two sides and an angle. So I have sine 30 degrees over 4. So sine beta over 4 is equal to sine alpha over A, and A is 5. So I start off by solving for sine, or solving for sine alpha. So I get 5 sine 30 over 4 is equal to sine alpha. Okay, so let me rewrite the equation. Sine alpha is equal to 5 sine 30 over 4. And now I need to solve for the angle. So notice that's the only variable. I apply the inverse sine to both sides. And so the sine and the inverse sine cross off. And I get inverse sine of 5 times sine 30 over 4. And so that is 38.7 degrees. So alpha is 38.7. But remember that sine is defined, its range is in quadrant 1 and 4. So this is a positive value. So it could be in quadrant 1 or 2, and I don't know. Or, so I need to find the quadrant 2. So this is the quadrant 1 angle. I need to find the quadrant 2 angle. And so how I do that is I take 180 minus 38.7. And that gives me 111.3 degrees. And again, that's alpha. So I have two choices for alpha. Okay, so my first choice. If alpha is equal to 38.7, then gamma is going to be 180 minus 30 minus 38.7. And that comes out to be that gamma is equal to, well, I'm going to have to use my calculator. 180 minus 30 minus 38.7. Okay, it's equal to 111.3. Did I mess up on the last? Oh, hang on. I think I may have messed up. Okay. 180 minus 38.7 is 141. Okay. So that's my second quadrant angle. Okay, so if this is alpha, then this is gamma. Okay, and so what I have is sine of 30 degrees over 4 is equal to sine 113 degrees over C. and I solve for C. And I get C equals 4 sine 111.3 over sine 30. And that is, well, I don't trust my answers anymore since I screwed up a minute ago. Okay, 7.45. Okay, so at the end I'm going to have two solutions. So that was one solution. Alpha equals 38.7 degrees, gamma equals 111.3 degrees, and C equals 7.45, not degrees, 7.45. Okay, now the other possibility was alpha equals 141.3, in which case gamma would equal oops. 8.7. Okay, and now I use the exact same one I did earlier. Sine 30 over 4 is equal to sine 8.7 over C. C equals 4 sine 8.7 degrees over sine 30, which is 1.21. And so that's my second solution. Degrees, gamma equals 8.7 degrees, and C equals 1.21. So those are my two solutions. Okay. So let's see an example that is a side-side angle, but only has one solution. So this is example 2. A equals 3, B equals 2, alpha equals 50. So we get sine of 50 over 3 equals sine of beta over B, and we solve for sine. We start off by solving for sine beta, so we get 2 sine 50 degrees over 3. And so beta is equal to the inverse sine of 2 sine 50 over 3, which is 30.7 degrees. So that is one possibility. This is the Q1 angle. Okay. What about the Q2 angle, the second quadrant angle? So what we do is we take 180 minus the answer we just found, and we get the second quadrant angle is 149.3. Okay, now what do we do with that information? Okay, so if beta is equal to 30 degrees, gamma is going to be 180 minus 50, that's angle alpha, minus beta, which comes out to be 99.3 degrees. Okay, so now I need C. side C. So I take sine of 50 over A is equal to sine gamma over C. And I solve. 3 sine 99 over sine 50 degrees, which comes out to be 3.86. So there's one solution. The next solution, okay, I take my second quadrant reference angle. So that would be beta equals, I guess it's not a reference angle. It's my second quadrant angle. Okay, so beta is 149.3 degrees. So I take 180, so I'm trying to find gamma. Gamma is 180 minus 50 minus 149.3, which comes out to be negative 19.3 degrees. Since we're talking about triangles here, all their degrees are positive, all their sides are positive. So this is not possible. So if beta is 149.3 and our alpha is 50 degrees, gamma is negative, which is not possible. So there's no second solution. There's only one solution, and it's on the previous page. All right, here's another example. B equals 5, C equals 3, beta equals 100. Okay, so I start off, sine of beta over B is equal to sine gamma over 3. And I solve for gamma. So gamma equals, that's going to go to the other side, inverse sine of 3 sine 100 over 5. And that comes out to be 36.2. All right, so if gamma is, so this is my Q1 angle. Okay, so now I've got gamma equals 36.2. So what is alpha? It's going to be 180 minus 100 minus 36.2. And in that case, I get 43.8. So sine of 100, which is beta, over B is equal to sine of 43.8 over A. Solve for A. And I get that A is equal to 3.51. So there's my two angles that I needed and the missing side. Now, I found a second quadrant reference angle for gamma, and it can be calculated as 180 minus the angle that I found. Okay, and so if gamma is 143, what is alpha? So take 180 minus gamma minus the beta angle that I was given, and I get a negative value, negative 63.8, which is not possible. So there's only one solution. All right, I think here's the last example. Okay, example 4. A is equal to 2, C is equal to 1, and gamma is equal to 25 degrees. So the first thing I do is set up. So I have gamma, so sine 25 over 1 is equal to sine alpha over 2. So alpha is equal to inverse sine of 2 sine 25, which is 57.7. Okay, so if alpha is 57.7, what is the remaining beta angle that I have? So I take 180 minus gamma minus alpha. And that comes out to be 97.3 degrees. So using that information, I get that sine of 25 over 1 is equal to sine of 97.3 over B. Solve for B. So I get sine of 97.3 divided by sine of 25, which comes out to be 2.35. All right. Next, I find the second quadrant reference angle. So if the first quadrant reference angle is 57.7, then the second quadrant reference angle is 122.3 degrees. And again, that's for alpha. So here I'm going to get two solutions because I get two possible angle measures for angle alpha. Okay, so I get sine of 122.3, which is alpha, over A is equal to sine of I haven't figured out the other one yet. Over 1. So, oh no, wait, not over 1. Over the thing I'm trying to solve for, which is B. Okay, so B is equal to 2 sine 32.7 over sine 122.3 degrees. And that gives me beta equals 1.28. Oh, wait a minute. Okay, so this is the right answer. And where did that come from? Well, let's see. I calculated alpha. I was given gamma. So what we need to find is beta. So beta is 180 minus 22.3 minus 25, and that comes out to be 32.7. So that's where that 32.7 comes from. I found alpha. I needed to calculate beta to find B. So in summary, solution 1 alpha equals 57.7 degrees, beta equals 97.3 degrees, and B equals 2.35. Solution 2 has alpha equals 122.3, beta equals 32.7, and B1 is equal to 1.28. All right, so you've seen two examples where you got two solutions and two examples where you got one solution. And so this is for when you have two sides and an angle, but the angle in between, the angle is not in between the two given sides. So, okay, that is the law of sines.